countdown.
Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hello, students. Hello, how are you? We meet here again today. So, welcome to Pusat Tuisyen Academy YouTuber, a joint venture with e-didik Malaysia and Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Before we proceed, let's begin our session with the recitation of your prayers according to your religion. Okay, how is everyone doing today? I hope everyone is healthy and safe and ready to proceed to today's class. Now let me introduce myself. First, I am Teacher Eileen as your moderator for today. And together with me is our presenter, Teacher Zainariah, as we known as Cikgu Zana. And also our Teacher Im from College Tingkatan 6 Tapah Perak as our host controller for today. And also we have Cikgu Rosmaya as pemerhati, and she's teaching it at SMJK Yokhwa Kajang, Selangor. Madam Rosmaya is teaching physics. Okay, so for the record, we are now live in Teacher Zana's channel. So as a sign of support to Teacher Zana for the hard work in preparing today's lesson, please subscribe. Okay, subscribe her channel. Okay, not forgetting also to Teacher Im channel and also Cikgu Rosmaya's channel, also myself, Teacher Eileen. So, as usual, the lesson will last approximately for 1 hour. And for your information, starting from 24th of May, at the end of the lesson, there will be 2 links. Okay, 2 links will be given at the end of the lesson. One is, as usual, that is the certificate link for you to claim your e-sijil AYU. And remember to use e-didik email to fill in the certificate link. And another link is for you to claim the AYU credit. So what is AYU credit? So I think let me invite Teacher Im to explain to you what the AYU credit is. Let me invite Teacher Im to explain to you.
Siapa duluan? Tak dengar.
Hi. Right. Today I would like to tell you what's about the AYU claim first. All right. So the credit claim for AYU you can get from the link here, and the link will be given to you at the end of the class. So you will go to the link and you will look at this video first, learn up about the how to do it first. I'm not going to show you, but you have to fill in a Google form. So the email that you are using here will be the email for you to claim your record edit credit record, will be the email you use for e-didik. Means you will get an e-didik email. If you have not got your EDD email, you can look at the description box. There is a place where we say daftar email EDD di sini. You can click on that link and you can register for your EDD. Okay. So you will look at this record email is your EDD email. Don't give other emails because other emails will not be able to claim your EDD. And then
Yes.
you have a code class. Okay, for the code class, we will give you in stages. So when the class has already go on like about 5 minutes, you will get one number. Then after another few more minutes, you will get, you have to be peka lah. You kena peka lah. You have to be alert on when the number will be coming out. Okay, so we will tell you, okay, the second code is, the third code is, the fourth. You will claim, you will get 4 codes. At the end of the class, you will get 4 codes and you will go to this link and you will enter 4 codes. All right. So when they say next, you press next, they will ask you for your IU code, the IU number, and if you cannot get the IU number, then you will go for the EDD, okay, website. Okay, what do you do with the credit? Okay, so what you want for the credit is you go to this part here, on top here, you go to credit IU, you press on it. You press on it and wait. Okay. You press on it and you will see catalog ganjaran. Okay. Catalog ganjaran. You scroll down to the catalog and you will see things that you can claim with your IU. So IU 1,500 means it is your credit, is your the numbers, the credit that you can get from the EDD, okay, which means now you not only get free lessons, you also can claim prizes from Academy YouTuber. How cool is that? The lessons are free, we are doing all the job, and we are pocketing out money for you to get presents. Okay, so there are calculators. If you don't like, you want board games, you got board games. You want name tag, then you got name tag. And you also got vouchers, Shopee vouchers, which you can go and buy anything from Shopee or Lazada. Depends on what the vouchers you get. You can get earphones and a lot more present. Okay, you can claim a lot of things from IU, and this present will continue to upgrade. Okay, and the most interesting prize I saw is now I kind of scroll down, but we are not eligible to claim that. Okay, only you all can claim. I saw something very cool just now. Okay, I think it's a handphone or a tablet. Okay, you can also claim smartwatch. How cool is that? Free lessons, free presents. Okay, mouse and so on. I want to go to the one that I saw. It's a very handphone or something. Okay, don't know where is it already. There you are. Okay, 2,400 credits and you can get a Samsung Tab S6. How cool is that? Okay, so that's about all that I want to say. You can go and learn about this credit IU and claim it. So I will return back to you, Cikgu Aileen, so that you can pass the class back to Cikgu Zana.
So you see, since the link is given at the end of the session, so be sure to follow the class up until the end and give your full cooperation in making this session a lively one. So I would also like to remind students to use appropriate language and also use appropriate profile picture if you wish to post comment in the chat box. I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So stay focused, and if you have any questions, please write on the chat box, and our teacher Zana will try to provide you with the answers. So without further ado, please welcome Cikgu Zana.
Okay. Right. Good afternoon and Assalamualaikum to all the students who have managed to attend today's class. Okay. So before we start our lesson, okay, I would like to share. Can I share my slide now? Okay. I would like to share our playlist. Okay, so we have a collection of mathematics form 6 lesson video. So this is the playlist, okay? And also we have a special playlist on calculus, chapter 2 in semester 2. And this is the URL. Besides this playlist, we have a pre-U collaboration lesson made for students. Okay, this is also the link. So in this pre-U lesson called collaboration, the teachers in the mathematics and science panel have prepared a few video lessons on chemistry, okay, led by teacher Cikgu Shannon. And we also have biology led by Cikgu Faiza. And we have also physics led by Cikgu Rosmaya, Madam Rasmaya. Madam Rasmaya is in the Conti, okay? And also not forgetting there's a special video collection on account. Okay, so students, feel free to watch and learn, okay, any information from the video prepared, especially for all of you, okay? Right, now, so today we're going to look at differentiation, and our main focus is derivatives of implicit functions. Okay, but first we have to...
Cikgu Zana, do you want to review the first class code for the first class?
Oh, yes. Okay, the first class code is 7. Okay, the first digit. We have a 4-digit credit code. Okay, so the first digit is 7. Take note, is 7. Okay, it's not going to be typed, students, so you have to remember. So you have to write somewhere. The first digit is 7. Okay, now let's go back on getting to know what are implicit functions. To understand implicit function, okay, we have to understand what are explicit functions. Okay, so the functions that you have seen throughout since Form 1 until now are normally explicit function. For example, here the dependent variable y is expressed explicitly in terms of the independent variable x. Okay, so notice that for explicit functions, y is the subject of the formula. Okay, so implicit functions, on the other hand, okay, are usually given in terms of both dependent and independent variables. For example, here we have y minus x squared minus 3x plus 8 equals 0. So y, which is the dependent, okay, are both presented with the independent variables. Notice that from the explicit function here, you can rewrite into the implicit form, and vice versa. From the implicit form, you can write to the explicit form. But this is not always the case, okay? Sometimes there are conditions whereby it's not possible to express a function explicitly. For example, here, okay? It's not convenient for us to express y in terms of f of x. So now our main question is, how are we going to differentiate this type of function known as implicit functions? Okay. The rule is simple, okay? We just differentiate, okay? We just differentiate each term of the equations with respect to x. All the terms in the equation, okay? And if you come across any term as a any term in a function of y, here gy, or the variable y to the power of n, okay, you differentiate macam biasa like normal, okay, you differentiate the variable y or the function gy, but you need to multiply by dy dx. That is the rule. Okay, so an easy tip to remember, you just differentiate the variable y and you multiply the result with dy dx. So please do not forget this. This is the most common mistake, my students. They differentiate the function in terms of y, but they forgot to multiply by dy dx. Okay, next step. Okay, you have to rearrange so that dy dx becomes the subject of the derivative equation. Normally, dy dx is always in terms of x and y. Okay, so that's how we're going to differentiate implicit functions. Okay, let's look at the first example. Okay, I'm giving you an easy example, but take note, students, okay, in order for you to master the derivative of implicit functions, make sure all of you have already acquired, okay, to differentiate all types of function, be it logarithmic, exponential, trigo functions, okay, and last week we have done the inverse trigo functions, and also the simple algebraic functions. Not forgetting, students must also acquire how to apply the rules of differentiation. For example, the product rule, the quotient rule, or the composite rule, etc., etc. Okay, right. So as I mentioned earlier, okay, this is the implicit function. To get dy dx, we differentiate each term with respect to x. Okay, let's look at the first term, which is ln y squared plus 1. Okay, so how do we differentiate ln y squared plus 1? Remember, the formula, derivative formula is just f prime x over f of x. And since it is a function in terms of y, remember when you differentiate, you must multiply by dy dx. So the derivative of ln y squared plus 1 is, okay, here is 2y over y squared plus 1. And since this is in terms of y, so you must multiply by dy dx. Okay, now we move on to the next term, xy. Okay, this is a product of two functions, okay, student. So derivative of product of two functions, we have to use the product rule, okay. U dv plus v du. So our u is x, our v is y. So the derivative of y is 1, okay, students, 1. So we multiply by dy dx, so we have dy dx. Not necessarily you have to put 1 here, okay, tak perlu letak 1. Then here plus y, derivative of x is 1 also. So we have x dy dx plus y. Okay, students, you are encouraged to memorize this. When you see derivative xy, straight away we can write down as x dy dx plus y. They will ask this a lot, okay, commonly asked function. Okay, so we have differentiate each term, okay, with respect to x. So now we need to gather our dy dx, okay, kita kumpulkan dy dx. So here we have 2y or y squared plus 1. Okay, here bring x to the left hand side is minus x. Okay, simplify the expression in the round bracket, make it into a single fraction, algebraic fraction. So we have 2y minus xy squared minus x. Be careful in when you multiply out, okay, because this is negative. So that we have the common denominator as y squared plus 1. Okay, the next step is to cross multiply. So this is your dy dx in terms of y and x. Okay, you don't have to expand it. We can write in factor form. Okay, leave as it is. Okay, right. So this is the first example. Okay, now I'm going slowly because the first two example I'll be going slowly, and the next after that I'll go on fast. Okay. Okay, here we have a simple function again. Just that I want to highlight that we need to differentiate term by term. So ln y again. By now, all of you should know ln y is 1 over y multiplied by dy dx. And then the next one, You need to differentiate the two function, y multiplied by ln x, okay? So remember to use the product rule, okay? So y differentiate ln x with respect to x plus ln x differentiate y with respect to x. So we have y multiplied by 1 over x plus ln x times dy dx. Okay, next we have the exponential function e to the power of y. By now you know that the derivative of e to the power of y is just e to the power of y multiplied by dy dx. Okay, the right hand side here, you can skip this, okay? The most important step is this step, okay? Every term must be differentiated correctly, okay, to get the method marks, okay? So make sure each term is differentiated correctly. So next step is to, I forgot the minus ey multiplied by dy dx. Okay, next gather our dy dx, okay? You just gather all your dy dx, okay? And you simplify the expression in the brackets, okay, to make it into one single fraction, okay, and then you cross multiply. Again, okay, we have dy dx as y squared over x multiplied by, in brackets, 1 minus y ln x plus y e to the power of y. So students, it's actually easy provided that you memorize or you understood how to derive or how to find the derivative of all the functions, okay? Right, now, let's look at C, involving trigonometric functions, okay? We have x sine y plus ln y equal x squared. Okay, x sine y is a product of two functions again, students, so we need to use the product rule. Okay, the product rule is x differentiate sine y plus sine y differentiate x, okay? So derivative of sine y is cos y, but since this is in terms of y, so you need to multiply by dy dx. Always remember that, okay? You need to multiply by dy dx plus sine y, derivative of x with respect to x is 1. Okay, next, ln y. So what is the derivative of ln y? Yes? Anybody can tell? It's just 1 over y multiplied by dy dx. And lastly, derivative of x squared is simple, 2x. Okay, so write down all the derivatives here. Okay, and then gather your dy dx, x cos y plus 1 over y dy dx, okay, 2x minus sin y. And then simplify the expression in the brackets. Okay, same procedure, okay? So your dy dx is 2xy minus y sin y divided by xy cos y plus 1. Okay, thank you, Eng Chia Yao, support Madam Zainariah. Thank you very much, Eng Chia Yao, for supporting me. Okay, right. So these are the first three examples on how to derive implicit functions. Any questions so far? Okay. If there's no question, we move on to the next example. Okay, it looks simple, right? Given 6x squared minus cos, this time is xy, equal 3y. So we need to find the derivative of this implicit function. Okay, so by now, we know that the derivative of 6x squared is 12x. Okay. Derivative of 3y is 3, but you need to multiply by dy dx. Now, how do we differentiate cos xy? Okay, we have here the product of two functions, cosine xy. So we're going to use this rule. Okay, this rule is actually being derived by applying the chain rule. Okay, you can use the chain rule, but it's going to be lengthy. But this rule is provided in the reference book. Okay, So if cosine is a function, cosine of a function g, and we want to differentiate it, so we need to differentiate the function, multiply by the derivative of cosine gu. Derivative of cosine gu is actually minus sine gu. This applies for all the trigo function, okay, be it sine and tangent, okay. So now, since our gu is xy, so the derivative of gu, okay, by now you should know, is just x dy dx plus y. Remember? Okay, remember? So derivative of cos xy is actually negative sine xy multiplied by x dy dx plus y. So we can write down the derivative of cos xy. Again, the one in the square brackets here, square box here, is just to indicate the steps to explain the how we obtain the derivatives. Okay, so be careful because okay, you have to understand that students tend to make mistake of the negative sign. Okay, when you multiply out, please be careful on the negative sign. Okay, so negative x multiplied by sine xy, so negative positive become negative y sine xy. Okay, this is just write down. Okay, negative becomes positive, So please check out for your positive and negative. So now we already have our dy dx together, your dy dx. Okay, I'm bringing my x sine xy to the right hand side. So I'm left with 12x plus y sine xy. So my dy dx is 12x plus y sine xy divided by 3 minus x sine xy. Okay, now some students, they will do like this. You can also do like this. They bawa the 3 to the left side. So x sine xy minus 3, okay? And put a negative here in brackets, 12x plus y sine xy. Okay, like I said earlier, you can leave your answer in factor form. And if you were to simplify this expression, it will give back the same equivalent 12x plus y sine xy over 3 minus x sine xy. It's the same. Okay, both are accepted. Okay, so is it about to give another digit or what?
Yeah, I think so.
Okay.
Or
If I'm not,
maybe after the advertisement.
okay, right after the advertisement. Okay, all right.
So stay tuned.
Okay. So we take a break for the
Semua
advertisement.
sekolah ditutup hingga cuti akhir tahun 17 Disember 2020. Anda tak cukup bahan? Tak ada rujukan? Tak faham? Anda nak tuition tapi PKP? Jangan risau, kami di Akademi YouTuber dengan kerjasama Kelab Guru Malaysia dan e-didik Malaysia mengadakan kelas tuition online. Semua peringkat ada, semuanya secara percuma. Video PDPC pun ada. Apa ditunggu lagi? Layari www.academyyoutuber.com.
Dibawakan kepada anda oleh Akademi YouTuber.
Okay, we are back. The second digit of the code is 1. I repeat, the second digit of the code is 1. Okay. I mean, I'm tempted to mention the first 2 digits, okay, but we are only allowed to mention 1 digit at a time. Okay, I'm so sorry. So the second digit of the code is 1. Saya pula suspend. Okay, we continue with our lesson. Okay, here we have an explicit function. We are going slowly to application. Okay, look at the question. The question asks us to find dy dx in terms of x and y. Hence, meaning that you have to use your dy dx in terms of x and y to evaluate dy dx at 1, 1. Okay, so as usual, we differentiate e to the power of xy. Okay, again, we use the the composite rule or the chain rule is the same. Okay, so we have e to the power of xy multiplied by now you should know x dy dx plus y. since GU is xy, so the derivative is x dy dx plus y. So this is our derivative. Okay, next is a product of two functions, but we have to use the power rule. Okay, remember the power rule? N fx n minus 1 multiplied by f prime x. So our f of x is xy squared. So power rule states that 2xy, and you differentiate xy, remember? Derivative of xy is just x dy dx plus y. So we have this. And obviously the derivative of 1 is 0. Okay? Right. So we have this. When you expand, okay, you multiply, we have the next step. Now, some of you might expand xy squared. It's still the same. If you were to expand it, okay, you have to use the product rule. X squared 2y multiplied by dy dx plus differentiate x squared, we have 2x times y squared. We have the same result, okay, the third line. Again, we gather all our dy dx, okay. Here I factorize y. Why? Because we need to find dy dx in terms of x and y. So here we can simplify exy plus 2xy divided by e to the power of xy plus 2xy is 1. So your dy dx is simple, just negative y over x. So at 1, 1, we substitute x1, y1. Our dy dx is negative 1. Okay, so slowly we are going to look at the application on implicit function. Next, proving question. Okay, so this is an example of a derivative, second derivative of implicit function. Okay, so first we differentiate implicitly this equation with respect to x. So the first one, we differentiate the first term, y times e to the power of 2x, okay. So by now, okay, now let me look at the comment given by the student. Okay. Okay. Okay, so what is the derivative of y times e to the power of 2x? Okay, y, you differentiate e to the power of 2x is just 2 times e to the power of 2x. And then we e to the power of 2x, you differentiate y is just dy dx. Okay, derivative of 2x plus 1 is just 2. Okay, now differentiate the second time. Okay, because you need to find d2y dx too. So again, you differentiate this term, y times 2e to the power of 2x. We have this, y. Derivative of e to x is 2 times 2, 4e to the power of 2x plus 2e to x, you differentiate y dy dx. Okay, am I going very fast? Okay, right. Next, you differentiate this e times dy, e to the power of 2x times dy dx. So derivative of e to x is 2e to x times dy dx plus, now e to the power of 2x, you differentiate dy dx, we have d2y dx too. Derivative of 2 is just 0. Okay. So now you add this, 2e to x dy dx plus 2e to x dy dx is 4e to the power of 2x dy dx. Okay. So now we multiply whole of this term by e to the power of 2x. Okay. So we have this. For y, this is being divided 1. So we have 1. 4 dy dx plus d2y dx2. Now, since this is a proving question, we need to conclude our answer. Therefore, and normally I advise students to conclude by writing down the same format as given in the question. Okay, students? Right. Next. Okay, this is a past year question involving the inverse trigo. So hopefully you remember what has been taught by teacher Im last week, finding the derivative of inverse trigo function. Here we have e to the power of y plus y, the inverse tangent 2x minus 8x cubed equals 0. We need to show that the gradient of this curve at the point where it cuts the x-axis is 24 over 4 plus 5. Okay, 6 marks, okay? Right. So again, we differentiate implicitly. Sorry. I'll start off by finding the point where it cuts the x-axis. Okay, so the point where it cuts the x-axis, our y is 0. So substitute y0 into the equation. Substitute 0 here. This is 0. Okay, we have x cubed equal 1 over 8. So our x is 1 over 2. Okay, now to find the gradient of the curve, we must find dy dx. Okay, so we differentiate implicitly with respect to x. Okay, e to the power of y, all of you by now should know what is e to the power of y. Okay, the derivative is just e to the power of y, and you need to multiply by dy dx. Now, how to differentiate this? The product of y with the inverse tangent of 2x. Okay, so if you recall back what teacher Im has taught you, the derivative of the inverse tangent f of x, we use this formula 1 over 1 plus fx squared times the derivative of f of x. So here our f of x is 2x. Okay, so substitute, we have 2x squared minus 2. Simplify this, we have 2 over 1 plus 4x squared. So applying the product rule, okay, y, so derivative of the inverse tangent 2x is this, okay, plus the inverse tangent 2x, okay, you differentiate y with respect to x, we have dy dx. Derivative of 8x cubed is 24x squared, okay, and derivative of 0 is 0. Okay, remember, our task is to find the gradient, to show the gradient is 24 over 4 plus 5. Now, since the question did not say find dy dx in terms of x and y, so straight away we can substitute, okay, x half, y 0 into the equation just now, into our derivative equation just now. Okay, so substitute x as half, y equals 0. Okay, so y is 0. So here 0, automatically this is 0. Tangent, the inverse tangent or arctan, 2x is half, multiplied by dy dx minus 24, multiplied by half squared. Okay, so simplifying, okay, you have this. Okay, straight away I substitute because the question did not say find dy dx in terms of x and y. It's not the same as the previous example just now. Okay, so now if you can remember, tangent pi over 4 is 1, right? Pi over 4 is 45 degrees. Tangent 45 is 1. Hence, the arctan 1 or the inverse tangent of 1 is pi over 4. So your dy dx, okay, sorry, dy dx plus the value of the inverse tan 1 is pi over 4 multiplied by dy dx, and I bring my 6 to the right hand side. Okay, gather your, okay, sorry, saya dah lupa. Multiply by 4 and then gather your dy dx. Okay, take out the common factor. Dy dx, we have 4 plus pi. So conclude your answer. Your dy dx is 24 over 4 plus pi. Okay, shown. So please, when you answer the question, ask, dia minta ke tak minta cari dy dx in terms of y and x. Okay? Okay, right. So far, so good. Any question? Kita akan go slowly. Okay, 40 minutes. Okay. Right. Now I want the students to try. Okay, this question. Again, this is application. Find an equation of the normal line to the curve. Okay, we quite lengthy implicit function here. X cubed minus 6x squared y plus 2xy squared plus y cubed equal 8 at the point where the curve crosses the y-axis. Okay. Okay, this is like an maths question which you have done, finding the equation of the normal line. Okay. Because we know that dy dx is gradient of a curve. So how to find the gradient of the normal line? Okay. I'm just stating the points so that you recall back, okay, the steps that you have done in Form 5, I think, Form 4 at Maths, Form 4 at Maths differentiation. Only that for Form 4 at Maths, your function is given explicitly, okay? Right, now, so first, what must we do? Okay? Again, we find the point where the curve crosses the y-axis. So, what happened when the curve crosses the y-axis? What is the value of x? I know there's 12 of you here watching. Not many students watching today. Okay, despite there's a credit given as bonus for you to claim. Okay, right. So what happened when the curve crosses the y-axis? Anybody? Okay, tak apalah, since we are running out of time. Okay. Okay, let me want to give you the second code, the third code. Come try, okay. Please students, come try to answer what happened when the curve crosses the y-axis, or what is the point where the curve cuts. Okay, good, Gao Min Chai. X is 0 when the curve crosses the y-axis. Good. Okay, Aina pun good. X is 0, because this is very basic, okay. This is basic understanding. When a curve crosses the y-axis, x must be 0. Okay, good, Yuan Chuan. Okay, so we substitute x equals 0 into the equation. Why? Because we need to find the y coordinate. Okay, so the curve crosses the y-axis at the point 0, 2. Okay, at the point 0, 2. Now, can all of you find dy dx? Because in order to find the equation of the normal line, you need to find the gradient of the normal line. To get the gradient of the normal, you have to find the equation, the gradient of the tangent. To get the gradient of the tangent, you need to find dy dx. So to get dy dx, you must differentiate the curve, the equation of the curve implicitly. Okay, right. Who would like to try? So x cubed becomes, okay, I'm giving time to differentiate this implicitly. So while waiting, okay, is it cool of me to mention the third code?
Yeah.
Okay, I already mentioned the first digit code, the second digit code. Now the third digit code, if I'm not mistaken, is 3. Okay, the third digit code is 3. Please take note, student. The third digit code is 3. So you have listened to the first one just now, second. Now this is the third digit code, which is 3. So the last digit will be given right till the end of the lesson. Okay, let's try to differentiate the curve, okay, implicitly. All right. So x cubed, the derivative is just 3x squared, okay? Okay, 3x squared is quite lengthy, but this is Form 6 is deeper compared to Form 5. So this is a product of x squared y. So we differentiate x squared. We have 6 times 2, 12x multiplied by y. Okay, product rule, yeah, plus 6x squared. We differentiate y. So we have dy dx. In order for you not to go wrong, you have to do this slowly, okay, not to make any mistake, especially with a negative sign in front. Okay, next, plus 2xy squared. So we differentiate x first. So we have 2y squared. And then we differentiate y squared. We have 2y dy dx multiplied by 2x. Okay. And then we differentiate y cubed, which is 3y squared. Remember, this is in terms of y. So we need to multiply by dy dx. And the derivative of 8 is 0. Okay. So next step is to expand this. Oh, sorry. Sebab dia tak minta ya. The question did not ask to find dy dx in terms of x and y. So straight away, I substitute x equals 0. Okay, good, Gao Mincha. You already managed to get the answer for me. Okay, you substitute straight away x equals 0, y equals 2. Okay, into the derivative of that first implicit function here, this one. So this is 0, x, anything with x is, anything with x 0 becomes 0. 0, this becomes 0, this becomes 0, this becomes 0. So you are left with 2y squared. So y squared is 4 times 2 and 3, 2 squared, okay? So you have dy dx negative 2 over 3, good. Remember, dy dx is what? Gradient of the tangent, okay? Sorry, it's lagging. What is the our class? Okay. Okay. Right. So the gradient of the tangent is negative 2 over 3. Okay. So the gradient of the normal. Okay. There's so many ways of teachers explaining this. Some will say M1 times M2 is negative 1. So if M1 is negative 2 over 3, so our M2 is 3 over 2. Or gradient of the normal line is negative 1 over gradient of tangent. Okay. This is how we get 3 over 2. Okay. So now you have already the gradient of the normal line, which is 3 over 2. And you already have the point 0, 2. Okay. So the simplest formula to use is the mathematics formula of an equation of a straight line, which is y equal mx plus c, because this is the y-intercept 2. M is given. So the equation of the normal line is y equal 3 over 2x plus 2. Okay, so thank you, Gao Ming Chai. You are so good. Okay, you already find the equation of the normal line. Okay, now let's move on to the next example. Okay, this is different because here the question says that you have to find dy dx in terms of x and y. Then find the coordinates of the stationary points. So the questions are similar to the SPM at maths question. The only difference is the function. Okay, the only difference is the function. So I feel that students can master this topic easily. Okay, because they have done this in Form 5. Okay, right. Can somebody find the dy dx in terms of x, y? So clue is to use the power rule. X squared plus y squared, the whole thing squared. So you can use the power rule. Okay. Okay, this is simple to differentiate. 2x squared is very simple. 2y squared is also simple. And this is in terms of y. Don't forget, multiply by dy dx. So this is 3 marks, finding dy dx in terms of x and y. Mostly students will score implicit function. Okay, provided that they know all the rules and the derivative of all the functions. Okay, so applying the power rule. Yes, so try to do the first term first. X squared plus y squared, the whole thing to the power of 2. So the power rule the composite rule states, you can use the chain rule, you can use by substitution, macam-macam ya. One thing about maths, there's so many ways of solving, but choose the easiest way to solve, okay? Right. Yeah, since So here, using the composite rule or power rule, 2 power 2. So x squared plus y squared maintain. Here become 1. Okay, the power 2 minus 1 is 1. And we differentiate, okay, the expression in the bracket, x squared plus y squared. So derivative of x squared is just 2x. Derivative of y squared is 2y. But since this is in term of y, don't forget, multiply by dy dx, okay? Next, we have 2x squared. The derivative is 4x. And here we have 2y squared. The derivative is 4y. Since in terms of y, we have to multiply by dy dx. The rest is just pure arithmetic. Okay? The rest is pure arithmetic. Okay, so first we take out 4 here. 2 times 2 is 4. Okay, take out, factorize 4. Okay, this step here can be omitted if you want to. Ya, tak buat pun tak apa, nak buat pun tak apa. Okay, so you are left with x squared plus y squared multiplied by x plus y dy dx equal x minus y dy dx. Okay, like I said, the rest is just arithmetic. Okay, so next we need to multiply the expression x squared plus y squared by x squared plus y squared by y dy dx. We expand, yeah? So we have this x multiplied by x squared plus y squared plus, I write y clearly here, y x squared plus y squared dy dx equals x minus y dy dx. So, panjang sikit, tak apa students. One thing about form 6 ni, you have to be patient, okay? Okay, just imagine this is 10 marks here. So that's why you can score actually in STPM, okay? Because implicit function is very simple. Just that you have to be patient when you are differentiating. Okay, next, what do? We expand again. We expand again and gather our dy dx. Tak nak expand pun tak apa. Up to you, because this is how you manipulate. Okay, you manipulate the operation, the mathematics operation. So here y x squared plus y, saya tak explain, but I gather my dy dx. Okay. So x minus x times x squared plus y squared. Okay, now we simplify. Okay, saya tak simplify lagi. Up to you. You can use many methods of manipulation, mathematical manipulation. Okay, now I factorize because here I have x. Okay, I took out my x. So I have 1 minus x squared minus y squared over y times 1 plus x squared plus y squared. Now, some of you might say, boleh tak saya tinggal macam ni? Boleh, but it's easier to express your dy dx in factor form. Why? Because we need to find the coordinates of the stationary points. Okay? Because we need to find the coordinates of the stationary point. So it's advisable to leave your dy dx in factor form. Okay, form 6 lain. Dia suka factor form. Yeah? Okay, now, 7 more minutes. So what happened at stationary point? What happened at stationary point? Okay, I'm really giving the answer. Okay, my hands are so itchy. Dia cepat sangat tekan the mouse. Okay, so what happened at the stationary point? Your dy dx is 0. At maths ini, concept at maths. So you have your dy dx just now. We equate it to 0. So you cross multiply. So you are left with x multiplied by 1 minus x squared minus y squared equals 0. Okay, this is in factor form. Okay. So your x is 0 or, okay, saya dah simplify here, x squared plus y squared equal 1, okay? So when x is 0, substitute into the equation of the curve here. Okay, when you substitute x0, your y squared plus 1, okay, factorize here. Okay, saya factorize. So I have y squared equals 0 or y squared equal negative 1. So which value of y are we going to take? Y squared equals 0. So we have to reject y squared equal negative 1 because y must be a real number. It's a real number. So we reject y squared equal -1. So here y is 0. So you have already found the first stationary point, x0, y0. Now, how to find the other or the rest of the stationary points? We use x squared plus y squared equal 1. So substitute 1 here, okay? And then we substitute y squared. Remember y squared from here, 1 minus x squared. Okay, we simplify. We have 4x squared equal 3. So x squared is 3 over 4. Okay, now, taking the square root, we have two values, positive and negative, so 3 over 2. Okay, so we have this. Okay, notice that when we substitute back into y squared, we are substituting x squared. Our x squared is 3 over 4. So it doesn't matter whether it's positive or negative, set 3 over 2. So our x squared is 3 over 4. So y squared is 1 over 4. So your y, again, we have two values, positive half, negative half. So our stationary points are, conclude your answer please, 0, 0, set 3 over 2, half, set 3 over 2, negative half, set 3 over, negative set 3 over 2 here, negative set 3 over 2 half, and the last one is negative set 3 over 2, negative half. Okay, so we have 4 minutes left. So I would like to say thank you for joining my lesson, and don't forget to subscribe to my channel. Okay, and okay, the last digit code. Okay, it's digit 7. Okay, students, digit 7. Okay, remember the first one, second one, third one, and the last digit code is 7. Okay, Teacher Eileen, back to you.
Okay, so remember the 4-digit code. So now we have reached the end of today's session. So congratulations to those who are able to follow our session from the beginning until now. So before we end our session for today, can you all please stop posting your comment for a minute and click the subscribe button and activate the bell icon so that you will not miss the next class session. Then if you find that the lesson was beneficial, click like and share to your friends on your social media, and spread and share the goodness. So now the link, I think the link for the CJ already in the chat box. I think the link for the credit also in the chat box already. Yes. So yeah. So please take note. The link will end 13 minutes for the after this, and make sure use EDD email. Okay, only to log in. Incorrect email used will not be entertained. So if you haven't got one, please apply. If you wish to get more information on the online classes, go to www.academyyoutuber.com. And to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all the students for joining today. Please share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all the teachers throughout Malaysia and all the students throughout the country. Thank you, Chu, for being a YouTuber Academy supporter. I think that's all for now. See you in another session. So remember hashtag bermula percuma, selamanya percuma. Stay safe till we meet again next week. Same day, same time. Bye.
Bye.
Stay tuned. Next week will be Cikgu Eileen's class, and next week we will be learning what, Cikgu Eileen?
The parametric differentiation.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma, mestilah Akademi YouTuber.
Dibawakan kepada anda oleh Akademi YouTuber.